our job is going to be first to write a hypothesis pair and then make a decision about whether to reject or fail to reject the null hypothesis. And then we'll restate our decision in terms of the original claim. The first thing we'll need to do is write the claim. Now, when we write a claim, once again, there are some questions we need to ask ourselves. Is it a mean or proportion claim? What symbol do we use? And is the claim null or alternate? Again, labeling null with HO and alternate with H1. First, let's ask ourselves, is this problem a mean or proportion problem? Well, we're given that the question talks about the mean amount of cola. Therefore, this will be a mean problem. And anytime we do the mean, our symbol will be mu. Therefore, let's start by writing mu. Now let's ask ourselves what symbol to use with this mu. Let's continue reading the question. The cola in a particular sized can is at least 11 ounces. Now let's remind ourselves of the language we use. At least means greater or equal to. Greater than or equal to is this symbol, a greater than sign with a dash underneath. So we'll continue by writing greater than or equal to 11 ounces. Now, is this null or alternate? Let's recall that null will be equal, less than or equal, or greater than equal, while alternate is not equal to, strictly less, or strictly greater. Here, our claim is greater or equal to. This places us underneath the null category. So we'll write that our claim is the null hypothesis, and it is that the mean is greater than or equal to 11. Second, let's ask ourselves, what's the opposite? We can also ask ourselves, is that opposite null or alternate? And also ask ourselves what tail it is. Well, the opposite of greater would be less. And since we've already got a null, the other one must be alternate. And because we've used equals in the null, we do not use equals in the alternate. In fact, we never use equals in the alternate. But we'll have the same symbol and the same numbers. Now, to figure out what tail we have, we look to the alternate. Now, the alternate says less than here in the middle. And since we have less than, that's left tail. Let's remind ourselves greater than would have been right tail, and not equal to would have been to tail. Now that we've written our claims and our tail, our third step is going to be to compare the big P against the level of significance. This significance level is represented with the Greek symbol alpha. There are two possible outcomes to this. You could have a big P that is less than or equal to alpha. Now, if your big P is less than or equal to alpha, that means you have strong evidence. And the lower your big P, the stronger your evidence is. If it's less than or equal to alpha, we have strong enough evidence to reject the null hypothesis. Now, in this case, notice that the null hypothesis is also the claim. This means not only are we rejecting the null hypothesis, we are also rejecting the claim. This won't always be the case, but it will be in this one. And once again, to reiterate, we're rejecting the claim because we have strong enough evidence to say that it's false. Now the other possibility we could see is that the big P is greater than alpha, in which case we don't have strong evidence. Now, this means if we don't have strong evidence, we cannot reject the null. Because you can only reject the null if you have evidence that's strong. Now, this isn't to say that we don't have any evidence, just that it's not strong enough to allow us to reject the null. In statistics, we call this a failure to reject. This means that the evidence that we've gathered is not strong enough to disprove the null. That means we don't reject the claim in this case. Because we haven't disproven the null, we must keep it. We can't say the null's false unless our evidence is strong. So we have to hang on to it. Now, this does not mean that the null is automatically true. It just means the evidence we've gathered is not enough to prove it false. The evidence doesn't really tell us enough to allow us to cross out the null and keep the alternate. Now in our case, our big P value is 0.097 and our alpha is 0.01. 0.097 is definitely greater than alpha 0.01. That means we cannot reject the null. And in statistics we say this is a fail to reject situation. Therefore, we will box in the null to remind ourselves that we can't disprove this. And so we have to stick to this and say that mu is greater than or equal to 11 based on our evidence. So we'll say that we cannot disprove the claim. Once again, this doesn't mean that the null has to be true. It just means that the data we've gathered does not allow us to cross it out.